Okay, welcome back to Engineering Economics. In this chapter or this module, we are going to be focusing on using Excel to do all of the work we have done up until this point in the class. So our goal then is to be able to use Excel and kind of navigate quickly through various types of interest rates in order to be able to make a recommendation for our client. So let's jump in and see how this works. So I'm going to start off with this example. The Student Engineering Society is building a snack cart to raise money. Members must decide what capacity the cart should be able to serve. To serve 100 customers per hour costs $10,310, and to serve 150 customers per hour costs $13,400. The 50% increase in capacity is less than 50% of the 10,310 because of economies of scale, but the increase in net revenue will be less than 50% since the cart will not always be serving 150 customers per hour. So that's kind of extraneous information that we don't necessarily need. The estimated net annual income for the lower capacity is $3,300, and for the higher capacity, it's $4,000. After 5 years, the cart is expected to have no salvage value. The Engineering Society is unsure what interest rate to use to decide on the capacity, make a recommendation. So we are going to see this a lot in this chapter, the question of what interest rate should we use? I mean, it would be great if we could go out to the bank and say, I want a 2% interest rate, but it's not like that in real life. What it really means here is we are going to make a recommendation or something called a choice table, which is going to be new to this chapter, based on different interest rates. So in order to kind of create these choices for our client, we are going to need a graph. So that's kind of where we're going to start in all of these problems, okay? So I just kind of summarized the information we're given in this table in Excel so I can use it as a reference. So I have a nickname in the first column, I have low capacity and high capacity, and you'll notice that I now have an increment, which is going to be high minus low. So for my incremental analysis, if you remember that from the previous chapter, I'm going to use that when my useful lives are the same or when they can be made the same. So in this specific case then, my useful life for both is going to be 5 years. So I can use an incremental analysis. If you remember, that means my present worth is going to be equal for my increment, and we'll analyze it that way. So I'm going to then have a capacity of 100 customers and 150 customers. And then the cost, I just formatted these in Excel in accounting. Accounting's my favorite. Basically what that does is it gives me parentheses around the negative numbers. So if you look up in my formula bar, I have negative 10,000 written there. So the parentheses just tells me it's already a negative. Okay, so then I did my high minus my low, and I get the 3,090. And then I have my net annual income for each, and then the income for my increment. Okay, so now the first thing I want to do is to find my present worth for my low, for my high, for my increment. And I can do my increment one a couple ways. I can just do my high minus my low here, or I can do the present worth analysis just on that value. We'll kind of decide in a few minutes. But okay, so in order to get here, then I need to find my factor. You'll notice here I have a bunch of interest rates written down, and that's because I'm going to make a graph of present worth versus interest rate. So I need like a myriad of interest rates or a spectrum. So I'm just going to use all the ones that the textbook has to offer. So I'm going to go from 0.5 all the way up to 20. Okay, so some of you might be wondering why I need a factor. So I kind of wrote down, because I'm so used to it, right, how to get present worth from these values. So I said my current present worth, or my present value, is going to be equal to a negative initial cost plus my annual income I receive multiplied by my factor. And my factor then is going to be I want present worth given an annual amount. Okay, so I need that P given A factor. So I'm going to go to my engineering table, and I'm going to find the 0.5% and my P given A factor. I'm just highlighting everything. Okay. And then for 5 years is going to be 4.926. So I'm going to go in my table and write 4.926, and that will be that. And I care about all of you so much that I will not make you watch me look up the factors for each of these, but I want you to know that is how I got it, is I manually just went to the table and picked them all out. It was such a delightful process. Okay, so now I'm going to actually get in it with these. So I'm going to say the present worth of my low capacity is just going to be my initial cost. So remember, that's already a negative. Okay, and then plus my income times by my factor. So I'm going to lock these two cells, and I'm sure you guys know how to do that, but in case you're wondering, that's just F4. So, and then I will drag that all the way down, okay? And then with my high, I'm going to do the same thing, but I'm going to now just reference these, pull these down to my high capacity, make sure this is B19, not C19. And then I will have my present worth of my high capacity. Okay, so I could just do the one minus the other, but I'm just going to use my values up above. It doesn't really matter. It would give you the same answer either way. Math is cool like that. So I have $82 like this, and it goes all the way down like this. Okay, so something to remember about incremental analysis is that incremental analysis means we want to find, so if you remember, the whole goal of incremental analysis is to find your IRR, or your incremental rate of return. That's going to happen where your present worth is equal to 0. So I can find that in a couple different ways. One quick way is to just look at my present worth of my increment column and see that, okay, it's above 0 here at 4%. At 4.5%, it's going to be a negative. So somewhere between 4 and 4.5%, I'm going to have a present worth equal to 0. So we're going to graph these so we can get a better idea of what's going on. I like the scatter plot with the smooth curves. Uh-oh, something is wrong. Let's go look at that first point. That looks wrong to me. Okay, so after looking at it, I think I was a little mistaken and got these backwards. This is 4.926, not 4.296. So if you guys were here in person, you probably would have corrected me. So I'm sorry about that mistake. Okay, so as I fix that, you'll see the graph looks much better, right? Okay, so I actually don't want my factors on my graph, so I'm going to delete that. So now I have this graph that is just my present worth versus my interest rates. And I'm going to type that. Okay, so now I can compare my present worth low, which is this orange line, to my present worth high, which is the green line, which is the present worth of my increment, which is this blue line. Okay, so I always bring on a vertical line just to kind of help me visualize things. So I'm now looking at a couple things. So once again, my IRR is going to be where my present worth of my incremental value is equal to 0. So we talked about that already, that we know that that's between 4 and 4.5. Another way to look at this is where my low value equals my high value, right? Because if my present worth high equals my present worth low, that's the same as saying my present worth high minus my present worth low equals 0, which is my present worth of my increment. So either way, I am wanting to find the value where either the present worth of the increment equals 0, which is here, or where these two lines cross each other, which is up here. They'll be at the same value. So to do that, I am going to use interpolation. If you need a refresher on interpolation, feel free to go back and watch that video. But I'm going to look at these data points of 4 and 4.5 and 26.4 and negative 17. So I'm going to set up that interpolation here. I kind of wrote that setup here. And if I do all of the calculation, I get an IRR of 4.3%. So that means then that my incremental rate of return is 4.3%. So that's super. That was the answer in previous chapters, but this time we're going to build on to that. So if we take a step back from just doing the calculations and ask ourselves what we want, we are going to tell our client to choose the alternative with the greatest present worth at any given interest rate. So what we're trying to do is we're trying to find the highest present worth in this interval, and we kind of found the cutoff for where that interval ends. And then we want to find the greatest present worth for this interval, which would be the orange line. So up here it's the green line, then the value that's the highest present worth, or the value on top, is the orange line, and the orange line stays on there forever. Okay. However, one funny thing kind of happens where all alternatives have a present worth that goes to zero 18%. And we can actually see that data point in our values, but past 18%, we're not going to do anything actually. So we're going to even tell our client, if the interest rate is greater than 18%, don't even worry about this project. It's not worth it. Okay, so now we need to write all of that down. So this is going to kind of be a piecewise function. I'm going to drag this down so we can see it as we write. So I'm going to say from 0, yep, I want to do a bracket because it's an inclusive and exclusive points. From 0 to 4.3, I want to choose the green line because it's on top. So I'm going to say the high capacity cart. Okay, and then from 4.3 to 18, I'm going to say choose the low capacity cart. And then from 18% to infinity, I'm going to choose no option. So I'm going to say no choice or no alternative. Or should I say do nothing? That maybe is better. Okay, so I'm going to say nothing. You'll notice I just had the infinity symbol in my copy and paste arsenal all ready to go, but you can also go find that in your insert symbols. So this is what my choice table would look like. I have basically a piecewise function saying during these intervals what to do. So then I would look at the bank or the credit union or the bond, whatever's available to me at that time. And I would say, okay, if the bank is offering a 6% interest rate loan, then I would come in this region and choose a low capacity cart. If it were offering a 2%, then I would come in here and I would choose the high capacity cart. Okay, so we are kind of putting together a lot of things that we've done so far, but this is my incremental rate of return in Excel. We will do it a different way in the next video, so see you soon.